All right, 8. Rectangular box. 2 of its dimensions are doubled, third dimension is unchanged. What does it do to the volume? I'm not really asking you to just think through it. I'm asking you to do some math here. So I'm not actually given any numbers, but I do know that if I wanted to find the volume of a rectangular box, it would be length times width times height, or base area times height, but that's what I would have. So if I want to double 2 of its dimensions, that's really what it is that I would have. And so if I simplify that, I get this. Now, what does that do to its volume? Well, if this is the original volume and this is the new volume, how much larger is the new volume going to be? Hopefully you figured out that it is 4 times as large. All right, number 9. Ratios of circumferences. Circumference is length. So this is R. And it is similar, so we are talking about R's. And I want to know the volume, so I need R cubed. And the large one is 400, and I want to find the small one. So when I cross multiply and do a bit of fun, I get that I have 118.52 cubic feet. Right, number 10. So D, we have the diameter is 5, which means the radius is 2.5. We have the diameter is 9, which means the radius is 4.5. So I have 2 smaller pipes, and then I'm assuming the pipes all have a length of 10, and I want to know what the new larger one would be. So really I'm trying to say that this one plus this one will ultimately give me this larger one here. So I need to figure out what the volume of this and the volume of this is. So let's do that. The volume of this one is base area times height. So pi r squared times height plus the volume of this, which is 4.5 squared, because pi r squared times height. So I have, I don't know, 2.5 squared is what? Whoops. 6.25, and 4.5 squared is 20.25. And let's go ahead and multiply by 10, so that moves the decimal, yeah. And then add them together, so 62.5 plus 20.25 is 82.75 pi. Now, is this exact? Yes, it is. And for the moment, we're going to go ahead and just leave it like that because I think it will make life a little bit easier. So now what I want to do is I want to set this equal to pi r squared, which I do not know, times the height. So now what I'm going to do is I'm going to divide both sides by pi. I'm also going to divide both sides by 10, which then gives me 8.275. And that is r squared. So I want to take 8.275, square root that. So the rate, did I do that wrong? I'm not getting the same answer that I just had. Same flow capacity as the 2 smaller ones. I found pi r squared times height, pi r squared times height, and then that needs to equal to pi r squared times height combined. Hold on, 2.5 squared. Well, that's not what I just got. Oh, that's funny. Nice, Alicia. Trying to make life easier, and I just made life much harder. By moving the decimal, I didn't really do it. How many of you guys noticed that? I moved it, but then I didn't actually do it when I plugged it in. So that was 62.5 plus 202.5. which is 265. Lovely. Oh, I don't want to make a mistake. Okay, so then 265 divided by 10 is that, and so that's my divided by 10, so that gives me 26.5. And then I want to take the square root of that, which gives me 5.147. And then I want to multiply that by 2, which gives me, there we go, 10.30. It's actually 295, but then when I round that up, I get 0.30. Whew! All right, so that is my diameter. Glad I was able to fix that. See, I make mistakes too. You just gotta find them. All right, so number 11, what do we have? We have a right cylindrical solid with a hole bored through it, all this information, and we want to find the total surface area of the solid, which means we need to first of all account for all of the different surfaces that we have. So we have the top and the bottom. We have the outside region, the lateral surface area, the outer, and then we also have this inner lateral surface area. We actually have 4 different surfaces that we need to account for. And so if big D is equal to 8, then big R is equal to 4. And if small d is equal to 2, then little r is equal to 1. And the height's the same for all of them. And so I need to find this here, which hopefully we recognize that if you just take the whole thing and get rid of the small little circle in there, it should be fine. So we're going to go ahead and do that. So that would be pi r squared minus pi r squared. So that is 15 pi, and I have 2 of them. And then the outer surface area is the circumference times the height. So that is pi times d, so 8 pi times d, or times the height, which is 48. And then the inner part is, again, circumference times the height. And I'm not subtracting that surface area, I'm adding it to it. It didn't exist before, so I'm not actually adding it to it. So that would be 2 pi times 6, which is 12 pi. So in theory, the answer is 90. So I'm really hoping all this adds up. We have 15 plus 15 plus 48 plus 12. Woo! 90 pi is our total surface area.